All right. So again, we're doing the review. We're starting with questions 6 and 7. Those are the first two that were asked for. Number 6, it says solve for x. So that one's pretty straightforward. We have the two angles that are labeled. Those are vertical angles, so we can say that they're congruent. So we're going to set them equal to each other. So we have 3x plus 10 equal to 2x plus 15. And then we can solve. So we can bring the 2x across this way. So we're going to subtract off 2x. And then we can bring the 10 in the opposite direction. So subtract 10. So those cancel off. Those cancel off. So we now have, on this side, just x. On this side, we have 5. That's our answer for number 6. 7 is a much more difficult problem. Because now on 7, they don't just ask you for x. They ask you for a specific angle. They ask you to solve for angle CAB. They want this angle here. Since they're asking for that angle, there are multiple steps before you can find the answer. Again, we still have vertical angles. So we have this angle is congruent to this angle. So we're going to set them equal. 6x minus 125 equals 2x plus 39. Subtract 2x. And then if we're moving the 2x over this way, we can add the 125 to bring it the opposite direction. So plus 125.
Do you have a black ink pen? Thank you.
So on here, 6x minus 2x, that's 4x. 39 plus 125. That's no, go ahead. Oh, not me. Oh, okay. All right. So 39 plus 125 gives us a total of 164. 164 divided by 4 is 41. Now, that is not the final answer. Our next step would be to take the 41 and plug it in for one of the equations we know. Doesn't matter which one you plug in for, because they should both give us the same thing. So we have 2 times 41 plus 39. Well, 2 times 41 plus 39 gives a total of 121. But that's this angle. So that still isn't our final answer. We now know that this angle is 121. We need this angle. These two have to be supplements. So 180 minus 121 leaves us with 59. And that would be our final answer. So again, this question is hard because it asks you to do 3 basic things. You have to first find x, then you got to plug it in and solve for one angle, and then you have to use that angle to solve for another angle. So again, there's a lot of steps here. So you got to be careful. You got to make sure that you're answering the question that's being asked. One of the things I noticed so far on the reviews when I've looked at the answers some of you guys have submitted online, for your answers, some of them don't match what the question is asking. For example, on this one, for number 7, I had quite a few people who put 41 in as the answer. Well, that was correct work, but not the final answer. I also had quite a few people say 121. Again, correct work, you're just not at the final answer. So make sure you're answering the question that's being asked. Same thing on the exam. Make sure you double check that your answer matches what was asked. Because although it is multiple choice, again, the entire exam for semester 1 is all multiple choice. But when you have multiple choice questions, the tricky part is, if you had a question like this, would you see 41 as an answer? Yes. Would you see 121 as an answer? Yes. And then, of course, you'd have the correct answer. I don't know what the fourth option might be, but you'd see the 2 most missed things as other answer choices. So be careful. Just because you see it as an answer doesn't mean you answered the question. So go back, double check that you actually answered the question. Brandon, can you, if you're going to shake your leg, move your bag, it's making a lot of noise. You know what I'm saying? All right, thank you. All right. Other questions? Go for it. 26? All right, 26. So 26 is on page 4. All right. On this one, consider the following statement. For two real numbers, a and b, if a is less than b, then a squared is less than b squared. Select all that can be used to prove that the statement is sometimes false. So what we're looking for here is a counter example. So we need, in order for it to be a good counter example, it has to be true for the if part of the statement. Again, if it's not true for the if, then it can't be a counter example. So start off with the if part. We need to find ones that work for the if. So a is -4, b is 3. That would work for the if. All right. So since that one works for the if, plug into the second part and see if it would work as a counter example. -4 squared is 16. 3 squared is 9. Is 16 less than 9? No. So that would be a good counter example. Now, it says select all, so there's probably more than one choice here. For the next one, all right, is 4 less than 5? Yes. If I plugged in here, I'd get 16 and I'd get 25. 16 is less than 25, so that's not a counterexample. It works for both statements. On the next one, -6 is less than 4. That's a true statement. -6 squared is 36. 4 squared is 16. Is 36 less than 16? No. So that's a correct answer. On the next one, A, again we had -1, B we have 2. -1 is less than 2. That's a correct statement. -1 squared, still just 1. 2 squared is 4. Is 1 less than 4? Yes. So that one works in both, so it's not a good counterexample. So the ones that work are A and B. And if we think about why this works, the original statement, you had to have a value that was less than B. The second statement, if you have a negative number, yes, it will be less than a positive number. However, if its absolute value, so if A's absolute value is greater, even though it's a negative, then it would prove that this part is wrong. All right? Because anytime you square something, the negative sign is going to go away. So essentially what we're looking for here was a negative number for A that was greater, that had a greater absolute value than the B value. All right, let's see, that was 26. What else? Go for it. 22.
Thank you.
All right, on 22, we have if measure of angle AEB. So this angle here is AEB. And DEC. So that's this angle here. What is the value of x? Well, these two angles that I just highlighted are what to each other? They are equal because they are vertical, right? They're congruent angles, therefore these need to be set equal. So 2x plus 32 equals 1/2 x plus 65. So now, go ahead and combine like terms. Actually, you know what? I probably wouldn't want to deal with this fraction of 1/2. So, you could do it as 0.5. That would work. All right. If you wanted to change that, you could. If you want to get rid of the fraction altogether, you could just multiply everything by the denominator and get rid of the fraction so you don't have to deal with it. That's what I would normally do. So that's the way I'm going to show this. Again, I'm multiplying everything by 2, just to get rid of my fraction. All right. So it'll be 64. This will now be x plus 130. Bring the x over, we'd have 3x. Bring the 64 over, we'd have 66, right? So you have 130 minus 64. You have 66. Divide that by 3, and we get 22. And that's our answer. 38? 48. 48.
It was 3x. I got him. No. It was 3x.
There you go. It's right there.
Equals 66. You didn't even have that, kid. You had it wrong. Really? I did? Dude, 1.5x.
All right. You said 48, right?
What you had? I still got 20 goods. I still got 20.
There's more than one correct way, Jaden, to get the correct answer.
I'm doing for you. Why would I copy yours?
All right. On 48. So now this one's based on what we just did on our last test, right? We have our triangle. We have an angle bisector. So then we can set up a proportion so that the side across from this is being split proportionally to the other two sides. So let me go ahead and write in these values. And when I do this, I'm going to go ahead and turn my paper here, just so you can see it. So 15, I'm putting in for this one. Then we have 18 goes in for NP. GP is 25, so this whole thing, 25. And GN, wait, did I write something wrong? Oh, no, sorry. GA, that's what we're starting for. We're going to call X. Now, if I'm looking for that piece, I still have to know what this piece is. So this piece will be the entire side minus the piece down here. And I'm writing a proportion. These sides over these two pieces. So 18 over 15 is equal to 25 minus X over X. That's the proportion I should be setting up. So 18 over 15 equals 25 minus X over X. Now we can cross multiply and solve. Well, before I cross multiply and solve there, I could reduce a little bit, right? Confused as to why I have these numbers? 48 was the one that was just asked for. 48. 48. I'm doing 48. Different sets of numbers for each of those. That's all right. So again, we got 18 over 15, and then 25 minus X over X. So now, we're going to cross multiply. But before you cross multiply, you can simplify it a little bit. 18 and 15, those are both divisible by 3. So divide 18 by 3, you get 6. Divide 15 by 3, you get 5. Now we can cross multiply. So 6 times X equals, again, this 5 gets multiplied to both of those values. So 5 times 25, 125. 5 times X, negative 5X. Bring this negative 5X over to the other side by adding positive 5X. So you get 11X equals 125. Divide by 11. This is not going to give us a whole number here. So you can either say X is 125 over 11, or if you round it, 11.36. Again, it didn't say what to round to, so 2 decimal places wouldn't be bad. Again, test will be multiple choice, so it's not going to have to tell you what to round to. All right, only one of the answers will work. All right, other questions? 53, and then I saw your hand. Which one? 53 and then 55. All right. So 53, 55, 52. All right. 53. Where's 53? Okay. On 53. This one, again, similar figures. This was the section we just did, right? It tells us how they're similar by the similarity statement. if measure of angle A is 75, measure of angle X is 50, what's measure of angle B? Well, A is the same thing as O. So this is also 75. They want us to find B. So we now have 2 out of 3 angles. So 180 minus 50 and 75. Subtract, and we got 55. All right, so that was 53. Next one that was asked for was 55. All right, here's Roger. Roger is 6 feet tall. Stands by a flagpole. Roger casts a 5-foot shadow. Same time of day that flagpole casts a 9-foot shadow. So we have 2 similar figures here. 2 similar figures. We know that these are similar figures because of AA. Because if this is going to form a right angle, we have a right angle there. The angle coming down from the sun has to be the same at the same time of day. So, or up to the sun, however you want to look at it. Those have to be the same. Angles are the same. Therefore, these are similar figures. We can set up a proportion. Again, I normally set it up so that I'm solving for my variable on the top left corner. So if I use x there, I'd say it corresponds with 6 in the other figure. And 9 would correspond with 5. Again, there is more than one correct way to set that proportion. You have 4 different ways to set up any proportion. So as long as your proportion matches with the correct opposite parts here, so 9 and 6 are across from each other, and 5 and x are across from each other, the next step should all be the same. Because 5 times x is 5x. 6 times 9, 54. Divide by 5, was it 10.8? That's our answer.
10.8.
Which is, in this case, A. Alright, so 52 and then 56. Alright, 52. Again, another similarity problem. We have 2 similar triangles. Again, you have to use, guys in the back. Again, you have to use the triangles here. You cannot use the proportionality theorems because the side you're solving for is one of the parallel lines. It's not one of the sides being split by the parallel lines. So we have the little triangle where x is. The side that corresponds to that would be 8 in the big triangle. The other side that's given in the little triangle is 10. And then the length that corresponds to 10, it's not 14, it's 24, that entire side. Because again, you have to use the similar triangles. So this little triangle to the big triangle, which is the whole thing. All right. So, we could reduce this a little bit. 10 and 24. 5 and 12. Cross multiply. 12x equals 40. Divide by 12. And that's not going to come out to a whole number. Let's see. 10 over 3 or 3.3 repeating. Guys, shh. Yes. Yeah. Yeah. So, to extend on that idea, this question becomes really easy if it's multiple choice. Because if this is a multiple choice test, which it is, we know that our proportions would have to be, or our ratios would have to be equal because they have to be proportional. So we set this up, right? If you, oh wait, I'm pointing at the wrong one, sorry. This one over here. we set this up originally. Instead of doing this work and solving, if you set up your ratio and plug your values in and just said, one of the answers was 3.3, 3.3 divided by 8, you get a value. This value divided by that, does it give me the same thing? Yes. You found your answer. Again, if you have the answers, the proportion becomes really easy because you don't actually have to solve it. You just plug the values in, see which one comes out to the equivalent value. All right. Again, take tests smarter, not harder. All right. We have 56 was the next one I was asked for. On 56, we again have similar triangles. We know they're similar because they said that we have parallel lines. So we have these two would have to be congruent, and these two would have to be congruent. Notice, how many similar figures do we have? 3. We have 3 similar triangles here. We have this really small triangle here in the middle, this medium-sized triangle, and the really big triangle. So you could use any combination to find missing sides here. So what conjecture states that these two are congruent? Well, we have 2 angles in each of those figures right now. Therefore, angle-angle theorem. There is a squiggle. Oh, yeah. So you thought it was the other triangle. Yeah. Yeah. So which can? Now again, this is conjecture. But again, springboard. For springboard purposes, all of our things were already they were theorems. We never called them conjectures in springboard. And so again, AA conjecture, A theorem, or AA criteria, as the book even called it. Any one of those would be acceptable. So it depends what they have as the answer, but AA would be correct. All right, on part B, they want to know the length of BC. Well, in order to find that, let's go ahead and label some of these other parts. So we have AE is 10, EC is 8, AC is 9, FD is 12, and then HC is 6. Now, yep, so we could go ahead and label that as well. So this little piece appears too. But do we actually need that for anything? No, because the only thing we could use that to solve for is AB, and AB is not one of the things we have to solve for. So we don't have to label that piece. All right. Now, BC. So to help with this, I'm gonna give these different variables. I'm gonna call this one X, this one Y, and this one Z, just for the purposes of plugging things in. All right. Now, guys. So BC, that's this piece that we're looking for. So I have that piece over. I need a piece that matches up to that same position. Well, 9 would be in the same position for the medium-sized triangle. So I'm going to do X over 9. Then I need a piece that's shared 6 and not 12, 6 and 8. Because I got to make sure I use the same 2 triangles. So little triangle to medium-sized triangle. Because I did little to medium. So little to medium. Alright, so now, again, you can reduce that. 3 over 4, cross multiply. I don't even have an answer yet. Stop. Stop pretending to pay attention. Shh.
No, that's not even.
I'm looking at 50.
Okay, I understand. I'm waiting for people to stop talking. Alright. So, We cross multiplied. 4 times x. 9 times 3. So that's 27. Divide by 4. 6.75. Alright, so we got one of the answers. Now, BH. So BH is this side. We could again use the little triangle and the big triangle. Alright, so I'm going to label this one as y. So that'd be y with 10. And I could use the exact same fraction that I used before. 6 to 8. Because I did little to big again. Sorry, little to medium. So again, do little to medium. Again, it could reduce to the same thing. Cross multiply and solve. Divide by 4. And that's what, 7.5? For HF, where's HF? Here's HF. Now,
Don't you have to like minus it, like what you do? So wouldn't it be like Z
Yep.
over
So
Z minus
we need
1.5?
we need yes, HF. Listen, we could do this a couple different ways, but we got to find a different piece before we can find HF. All right, we have y here at this point, right? So we could solve for the overall length of this first. So BF, if I knew that piece, then we know HF. Because once we know BF, then we can subtract the piece we just found in order to find HF.
But can you do HF, right? That'd be Z. So Z over Z minus 7.5 because that's the y, and then do 12 to 6, or no?
Say again?
So it's also confusing. Z, because that's like the whole thing. Then for that specific part would be. Oh wait, no, the big one would be Z minus 7.5. Wouldn't it? That's like the same thing with the angle bisection, isn't it?
Yeah, but what would you match it up with? Because we don't have.
Or no? I'll do it. Sorry. Because 12 is like the big one and the 6 is the small one. I know.
Okay.
Can you do that or no?
Okay, so we could use a proportion there. All right. Now, we could. So I could set this up directly to solve for Z.
But
Now,
you're gonna do that?
no, I will actually. I think I like that.
Oh.
But I'm not. Your proportion was slightly off, but
Oh well.
because I have this label as Z, not the whole thing. But guys, sorry, one more time. Z over 10 is equal to 12 over 8. You know, because this piece here is not the entire thing, right? The piece I'm solving for is just this little piece, right? So I could do that, all right? I could do it, and that would give me this entire length, and then I'd have to go back and subtract this value from it, and that would give me the value, all right? If you want to, you can do it that way, or you can set it up as one proportion. Either way works. So, for example, all right, I'm gonna use your proportion that you had, all right, for the most part. I'm just gonna change one thing. So, the little piece we have here, the y, we already found that is 7.5. This entire side will be that 7.5 plus z. So we did the little to the big, right? Or maybe this was your proportion. I don't know. One of you guys was referring to it as well. So, all right. Then, since I did little to big, I could do 6 to 12. Now, the other option is that we could have done the big triangle to the medium-sized triangle, and that would also work. Again, I would have different numbers, but it would do the same idea. All right. So either way, cross multiply and solve. On this one, we can reduce this side to 1/2. So now this is just 15 equals 7.5 plus z. Subtract the 17.5, and we get 7.5 equals z. So this part is also 7.5.
So I basically could just use the portion that I used and use my knowledge from the previous one and just subtract that, and I would start my answer.
Yep. Now, so again, you can do these with proportions. You can also do these with scale factors. So if you recognized going from the little triangle to big triangle, everything is just doubling, right? 6 to 12, that's double. So then I knew that this was 7.5, so then that has to double.
So the whole thing be 15.
So the whole thing's 15, and therefore that would also be 7.5. Again, proportions, scale factor, you can go either route, and you'll get the same answer. All right? So whichever one's easier for the problem. Sometimes it's hard to tell going into it, though, which one's actually going to be easier. All right. That was the last one that I had written down that somebody asked for. What other numbers do you want me to go to? What do you got? 51? All right. Give me a couple more numbers, and I'll just keep going. 50. Anything else? 54. 57. 49. 60. All right.
Did we even get to 60? No.
So,
I didn't understand.
all right. So these are the ones I'm going to go in order now from here. 51, 50, 54, 57, 49, and 60. All right. So go into 51 first. It's funny, most of the questions that you guys are asking are similar to the chapter we just got done doing. All right. On here, 51. Again, might not be drawn to scale, but it gives you this so you know which order to set them up in. All right? Find the value of x. Round to the nearest tenth. So, x is on PU. PU is in the same place as RS. So I'm going to do x over RS is 20. Then I have 50 in this one, so I'm going to use the 50. 50 is on the side that was QU. QU is in the same places as T and R. So T and R is 29. Cross multiply and solve. 29x equals 1,000. Divide. Get 34.5. A. So that's 51. All right, next one, 50. A triangle has sides of 12 feet, 14 feet, and 20 feet. The smallest side of another similar triangle measure is 8 feet. What is the perimeter of the smaller triangle? So, first thing I would do is add up all these so we know the perimeter of the big triangle. So, 12 plus 14 plus 20 is 46. So, perimeter of the big triangle is 46. So, perimeter of big. Alright? So now that we know the perimeter of the big one, set up your proportion. And I have 8. That's the smallest side, it said. So, that goes with the 12. What is that?
I have no idea. Only at one page. It's like half a page. It's okay. Mr. Spizak, I'm waiting.
Alright.
He's my ride, so.
Okay. Have fun in the courtyard.
Oh my gosh. Lord, how did you know?
Alright. On here. So, 8 over 12. We don't know the small triangle. That's what we're looking for. We just found the big one was 46. So, cross multiply and solve. Again, we could reduce. So this is 2 This is 3. 3x equals 92. Divide by 3. 30.6. Continuous. So yes, if you're rounding, say what's around to? Huh? That is the perimeter.
Wait, I thought it had to be like an exact number. So it can be repeating?
Yeah.
If that's the way that
Yeah, I mean, that's the way the problem is. I mean, if you wanted to round it, you could say 30.7.
I was going to, but wouldn't you get it all in one?
Not if it, again, it's multiple choice, so
But what if they have both?
I highly doubt they'd have both because they'd both be correct. They'd have to tell you how to round it, or tell you that they want an exact answer or something.
But you should you look at it the same time you look at it and then you oppose to it? Can't you complain? Go to the courtyard.
I mean, yeah, but
So they go to the bathroom. What?
all right. Other. Yeah. So okay. Sorry, that was 50. You guys asked for 54 next, so 54. All right. On 54. All right. These two, it says, are similar. It tells you how they're similar. It tells you SU is 10. And the side lengths of this one are shown. What's the perimeter of this big one? Now, again, the only, this was pretty much exactly like the one we just did over here, right? Perimeter of this one, add them up. 4 plus 5 plus 6 plus 7 plus 6.5. 28.5. Doing okay? You guys doing okay? Alright. So that's our perimeter of the little one. Now, SU is in the same position as QR. So, 6 over 10 equals 28.5 over the perimeter is what we're trying to find in the big one. Right here, 30.6 with the line over top, continuous. All right. Shh, guys. So this would be 3 and 5. Cross multiply. 3x equals 142.5. Divide by 3. 47.5. That's the perimeter. Because again, I used one side like the scale factor, and then I used the perimeter of the small one to find the perimeter of the big one. All right. Next one was 57. So if angle R is congruent to angle N, and we also already know that these vertical angles are congruent, we know that these two triangles are now similar because we have two angles. Therefore, AA tells us that they must be congruent. So now, they want us to find RO and OF. Now, the parts that correspond here, 8 and 10 correspond. Do you want me to keep doing proportions, or do you want me to show one with scale factor? Okay. All right. Here, I'll do this both ways. All right. So, 8 over 10. What?
Can I use this for the night? I need a blacking pen.
Can you keep it?
No, for the night. Just for the night.
No. Whatever. Yeah, bring it back to me. All right. So 8 over 10 is equal to, and then whichever side you want to solve for first, it doesn't matter. So let's do RO since it's listed first. Over 15, we'll go with it. Again, you'd have to reduce. So this would be 4 over 5, cross multiply, 5 times RO equals 60, divide by 5, and RO is 12. Now, if you were to do this with scale factor instead of doing it as a proportion, this, what we have right here, essentially is our scale factor, the 4 over 5. Because if you want to solve on this one, this would be your image, this would be your pre-image, because we have all the values there. So image over pre-image, you have 8 over 10. So then you take that scale factor and you use it to multiply the number that's over here to find the numbers over here. So if I take my scale factor, so 15 times my scale factor of 4/5, multiply by 4, divide by 5, you get 12. Again, that's how you do scale factor, if you wanted to do it that way. So, I'm going to do the next one with scale factor first. So, OF. Again, I have my same scale factor. 12 times 4 over 5.
Oh my god.
9.6.
Which is, you said 9.6? Yep. So again, that's using scale factor. I'll show it with the proportion as well.
Wait, what?
Wait, I did the wrong one. This is FO over 12. Again, that's with your proportion. It's essentially the same work either way.
No, because I know you're going to do it, so I'm going to out wasting time.
Oh, so, okay, so when it's proportion, you get to find multiple parts of the triangle, or whatever shape they have on a text. Once you simplify it, right, and that's just scale factor, you can just do that.
You could use your scale factor to, yeah. Again, image over pre-image.
That sounds way easier than
Again, either way works. All right, 49. Is that on this page? Yeah. All right, 49. Oh, same image up here, so you'd have to forget what I have written up there. You have GA, you have AP, you have NP, you have GN. So making sure you set the proportion correctly here. NP was 5 over NG was 15. AP 2x plus 3 over GA is 12. Okay, that would be the correct way to set a proportion for that one. This side could reduce. 3 and 5.
How?
Because you divide by 5. Oh, sorry. No, never mind. Shh. Divide by 5, you get 1 and 3. Which just means I just divide by 2 different numbers. Alright. So 1 and 3 are our new numbers. 1 times 12 is 12. 3 times that is 6x and 9. Subtract, you get 3. No. Yes.
3, yes.
Divide by 6 and you get 1/2. So 1/2 equals x. Yeah, something went wrong. I don't know what went wrong. Alright. NP was...
Oh, that's why you put 2x plus 3.
Oh, I forgot the plus x. See, that's why you should always draw on the picture, but I had already drawn on the picture for the previous problem, so
That makes sense.
let's try that again. So this was 5 plus x. I didn't have the plus x there. What was the bottom again? NG 15?
Yeah.
Alright, so we're going to have to do this one over. Yeah. Because I didn't have the variable on the other side. It makes it slightly harder, too. Alright, so let's see. 12. That would be 60. That's 12x. Equals 30x. That's 45. Subtract the 12, you get 18. Subtract the 45, you get 15. Divide by 18. It's still a crazy answer. 15 over 18, which both those reduced by 3. So 5 over 6, which is A.
Divided by 3 gives you 5, and then 9. Wait. 3 divided 6.
Yep. And then we got, let's see, 49, 60 was the next one that you guys asked for.
I'm so sorry that the week
Alright. On 60. Any point in the plane which is on the blank is equal distance from the sides of an angle. Wait. That was phrased funny. Every point in a plane which is on the blank is equal distance from the sides of an angle. So that'd be the angle bisector. All right. Every point in a plane which is on the blank is equal distance from the endpoints of the segment. That'd be a perpendicular bisector. The point called the blank is equal distance to the sides of the triangle. So that's the in-center. In-center. And then the point called the blank is equal distance from the vertices of the triangle. That's the circumcenter. So that one's just straight vocab. Alright. Any others you want me to go to?
Oh, yes. 68. 78.
You said 68, 78?
Yes.
Alright.
Oh, 61.
61.
And 62.
62. Alright, let's start with those. Alright, so 68. 68. And you did say 78, right? Alright, so 68. In this parallelogram, what's x? Well, opposite angles have to be congruent, so these two are congruent with one another. So 80 equals 4x plus 12. Subtract the 12, you get 68 equals 4x. Divide by 4, which would be, well, yeah, not 2, 1. You said 17? Yeah, and that would be 28, yeah, 17. And then let's see, 78. Alright, 78. The following conditional statements are true. Which of the conditional statements below have converses that are also true. If a figure is a square, then it is also a rhombus. So if we switch this around, would it still be true? If a figure is a rhombus, then it is a square. That's only sometimes true, so that doesn't work. Number 2, if a triangle has 3 congruent sides, then it has 3 congruent angles. If a triangle has 3 congruent angles, then it has 3 congruent sides. Right? If it's equilateral, it's equal angular. If it's equal angular, it's equilateral. So that's true. So that one works. For number 3, if 2 angles are complements, should be an S there, then the sum of the measures of 2 angles is 90 degrees. So that's basically the definition, right? And with definitions, if you write a definition as an if-then statement, it should be one that can be written as a biconditional. So all of them should be true. So if we had rewritten this in the other order, if 2 angles sum is 90, then they are complements. That's also true. So both of those, 1 and 3, work. I don't know if this is going to help with my voice at all. Thank you, though. Now, I've been sucking on cough drops all day. All right. So that's 78, 61, and 62. Back on this other page. All right. This one's dealing with our mid segments of a trapezoid. So we have, in each one of these are mid segments drawn in, right? Also, again, for a trapezoid, they could also refer to the mid segment as a median. But anyway, these are our mid segments. So they gave us this top piece is 32. They told us PQ is 20. They want RS. Well, this is the one that.
Isn't it you put them on top, you add them together and divide it by 2? Like top and bottom.
So the 2 bases divided by 2 equal the middle. Now, you can do that, but for this one, I'm trying to find one of the bases. So this is like, you could use what I call snowman method back when we did midpoint. Again, you can use that on a problem like this as well, because you have, this is the average of these 2, right? So if this is exactly in the middle of these 2 numbers, the distance you go to go here is negative 12. So go that same distance of negative 12, you'd be at 8. Because it's a mid segment. The mid segment is the average of the 2 bases.
So the picture can show it can fit in different segment and like it can show that one side is taller than the other, but you can always assume that that's always halfway so the other side is equal.
Mm-hmm.
Not equal, but
Equal distance, right. Or equal difference, yeah. Yes.
So when you're trying to find the middle, that's when you use the.
And that's where you really have to do the average. Okay. So I think this next one, call this one 20, this one X, this one 42. So if you average these, 20 plus 42 divided by 2, that'd be 62 divided by 2, which is 31. Right? On C, 22, X, and 42. Again, average them. 22 plus 42 divided by 2. That's 64 divided by 2, which is 32. Yeah. Well, I also was asked for 62, so I'm going to do 62 right below it first. Is it okay that I cut off the top one? All right, on 62, this is a trapezoid with bases TR and AP. So I'm going to go ahead and mark these as parallel since I know those are the bases. if measure of angle 4, sorry, not 4, I read that wrong. Measure of angle R is 132. Find the measure of angle A. Well, these two angles must be what compared to each other? Supplementary. So you're just doing 180 minus 132, which is 48.
And then is E congruent to angle R?
Not necessarily, not based on this information. That would only be true in isosceles trapezoid. It looks isosceles, but it doesn't say it's isosceles. So again, you can't assume. Should either say it's isosceles, or it would have to give you marks on the side saying that they're congruent. All right. 59 was the next one, and then you said 69 and 74. All right. What was the next one? 52? 72. All right. All right. Wait, which one did I just do? 62. So 59. All right, that's this one up here. Which cannot be a triangle. Right isosceles, obtuse isosceles, equilateral acute, obtuse scalene, and right equilateral. So, you can normally classify a triangle by angles and sides. So each one of these is correctly using one side and one angle classification. The ones that are messed up, though, is the ones with equilateral and equal angular. Equilateral and equal angular don't necessarily have to exactly match up with a corresponding thing all the time. Now, I'm not saying they're both messed up. So these other ones definitely fine. Right and isosceles, those can occur together. Obtuse and isosceles, those can definitely occur together. Obtuse and scalene, those can definitely occur together. Now, equilateral, for angles, normally you would say equilateral is equal angular. But an equal angular triangle, what are the measurements? They're all 60. So is it also true that they're all acute? Yes. Right? All three angles are 60. So that one's still okay. Now, the last one, right and equilateral. Well, equilateral, again, we just said all the angles have to be 60. So by definition, it can't also have 90-degree angles. So E is the one that does not work. So, let's see. 69. 69. Alright. On 69. In the diagram, what are the coordinates of midpoint AC? Here's AC. Right here, right? I mean, you don't really have to do the math for this one.
It's right in the middle.
It's right in the middle. It's on a diagram. This is at +1 and 1.5. Correct answer is U. If you wanted to do the math, you could. But again, you shouldn't have to. All right. All right. Wait. Did I?
Yeah, you did that right.
No, I don't think I did that right either. Hold on.
Yeah, it's not in the middle. You draw a line across.
No. Sorry. I am off. My eyes deceive me. My eyes definitely deceived me. 1, 2, 3, 4, 5. No, just 5. So 2.5. 1, 2. So it would be here. Ooh.
Can you do the math?
Yeah, no, yeah, okay, I lied. You can't just look at that. My bad. I thought you could just look at it. Usually you can, if they give you a diagram. Yeah. Lesson learned, it's not that one. It goes through that point,
No, I knew you couldn't do that.
but no.
It's not even.
No.
But is the testing based on
Paper. Yeah, for the semester exam, it's paper. Yeah, we can't have every kid in the school be on a computer at the same time.
Really goodness.
Think about it, everybody in the school is taking an exam at the same time. Yeah. It'd be like, crashing constantly. All right. So, so this is our formula. So we gotta plug those values into our formula. So for our x values, we have -2 and we have d. Well, it doesn't matter which one you really put first. If you look at the options here, though, looks like they put d first every time, so let's go with d first. D plus -2 over 2. Then we have, on the other one, our y's, 3 and 0. 3 plus 0 over 2. Well, this one, we can change the plus sign to a minus sign. This one, 3 plus 0 is still just 3. Can't really reduce those. So, S is the correct answer, not U.
I'm the best guesser in the world. I thought
Alright. Where are we at? 74 and 72.
Is there gonna be a proof thing like this, like in 71? I bet there is.
Oh, I'm sure there's a proof. Now, again, remember, it's multiple choice. They're not going to have you fill in every part of it. So,
It's just gonna be like fill in the
it could be like,
multiple choice.
most likely. 77.
All that work.
Alright, on 74. Again, this is where I'd use the formulas. Altitude equals part 1 times part 2 underneath the radical. Leg equals adjacent part times the whole.
That's what it was. I use that for the test. That actually helps. That actually helps. What's the second half of the equation? Oh, I get it.
Alright. I mean, it's logical, it's just long. No, long. Alright. 74. Let's see. We got x. So x is the altitude. So I'm going to use this formula. We have the two parts. So again, this would be altitude. So, and then we have the two parts would be 3 and 9. So x equals square root of 3 times 9. 3 times 9 is 27. That doesn't reduce nicely. Now, our Springboard book doesn't do much with radicals yet. The next section is heavy in radicals. I don't think they have radicals on the exam, but I'll have to double check that. But you can simplify this. Again, you had these last year. You had 9 and 3. Really, we could have done this without multiplying it together, because square of 9 is 3. The 3 would stay under. So
You can also do like a family tree, can't you?
you can do the factor tree, or you can do biggest perfect square.
Press that button in the calculator.
But sometimes.
But I hope you have the calculator that has that function.
Right.
You know, on the FSA,
That's why
most of these on the non-calculator part.
you gotta do on paper. See,
My phone doesn't have it either, so I can't do it in class.
You just need to learn. Alright. And y, let's see. Y is this leg. So, leg equals the adjacent part, which is 9. The whole is 12. So, 9 times 12. What is 9 times 12?
That's a good.
108.
108? Got it. Square root of 108. And again, it's not one that works out very nice. We could split that up into 36
It's K.
and 3,
It's K.
which is 6 radical 3, which is F.
Can you explain how you get the? Oh wait.
We're doing Y, not Z.
I knew that. Can you explain how you get the numbers on the outside?
So yeah, so again, fastest way of doing these is if you know your perfect squares. If you know your perfect squares, you're trying to find the biggest perfect square that goes into the number. In this case, it's 36. Then, once you have a perfect square, you can take the square root of a perfect square. So square root of 36 is 6. The 3, we can't take the square root of, so it stays underneath.
How would you do it without having the square root of 108 and how that divides?
All right, I'll show you an example in a minute. Let me do Z, and then I'll do an example with a factor tree. Let's see. On Z, it's another leg. The adjacent part this time is 3. And then the whole is still 12. 3 times 12 is 36. Square root of 36 is 6. It works out to a whole number. Now, if you're simplifying a radical, so let me go back to the 108. All right. So if I do the square root of 108, and you don't know what comes out of 108, factor tree, you're just taking out any factors that go into 108, and you can break it down to the smallest factors other than 1. Or, as soon as you get a pair, you can stop the branches of that side of the factor, because you're looking for pairs. So, give me a number, any number other than 36 that goes into 108.
Yeah, but I like.
9 times 12?
What if you don't know how to do?
Okay, so what you can do is go on your calculator and see what's divisible when, like.
Yeah, you just, any numbers. You can pick 2 if you wanted to. Right? You can do as many different ways. 9 breaks down into 3 and 3. 12 breaks down into 4 and 3. 4 breaks down to 2 and 2. Now, we're looking for pairs. Here we have a pair of 3s. Here we have a pair of 2s. So, 3 times 2 is 6. That's what's going on the outside. This 3 stays under. So you have 6 radical 3, which is what we had there. So, yeah.
So think of that as marriage, right? There's running so on, so it's just 3. Then you do the same thing with 2. Now you have 2 separate numbers, and just how you do it inside the radical one, you just multiply it outside. And you keep the radical.
Man, your example is so much nicer than the example I was going to do.
Oh, sorry.
No. It's more classroom friendly, I should say. All right, I'm going to tell you something that another teacher used to do, which I like using for this. So I'm going to do the same example again. I'm going to do it a different way, though. All right, let's say we pulled out 2 first. Because, again, it doesn't matter what number you take out first. So we have 2. If you divide this by 2, you get 54. All right, I know it's even. I can take out another 2, right? So, again, you don't have to do like the hardest numbers here. So that'd be 27. 27. I know 3 goes into 27. And then 3 and 3. Okay, you get the same numbers no matter what, right?
It's just a longer process.
Yeah. So now, on here, this radical, it's a jail. Right?
Oh.
It's a jail.
Yeah, no one wants to see that number.
No one wants to stay in jail, right?
I mean, I don't need that number.
A lot of people want to escape from jail.
Yeah.
So these numbers are trying to escape. And in order to escape, they have to have a partner. But not everybody's going to make it. There's a guard in the there's a guard in the tower.
Only 2 people can get.
So these 2 have a partner. They're going to make a break for it. But guess what? Only one makes it.
No.
So that 2's on the outside.
Don't give jail people AKs.
All right. Oh, look, we got a pair of 3s. They buddy up. They try to make a break for it. Boom.
One's out.
Only one made it.
Wow.
This other guy, he doesn't have a partner. He can't escape. He's still in jail.
For him.
So 2 times 3, 6. 3 underneath.
The guys
What
go
about
to
that 4?
suicide.
You
Like,
use
they
the
know they're
difference
dying.
up there. What about that 4?
Hey, chances are 50-50. One of them's gonna make it.
Right.
They'd rather try to make it.
Right.
What about, okay, so the example that you used on the number was 9, 4. What about that 4?
Wait, hold on. My screen just went dead on me. What was that now?
The other example that you used, like,
Here?
what about that 4?
It's not the end of a factor tree. Again, you only use the ends.
Oh, yeah, okay.
All right. So again, there's many different ways you could have done a factor tree for that one. All right.
Where's the rocket ship that we'll be launching? These are the coordinates. A rocket ship.
What are you talking about right now?
So in math, last year, my teacher, one of the problems with the rocket ship, so like she was making fun of the fact that math, you're launching a rocket ship because you're not going to need this to work.
Where's the rocket
So,
ship?
yeah, like, where's the rocket ship?
You look so bad. You so.
I'm gonna put one on there.
Yeah, you see. Oh yeah, that's the rocket ship. Blasting off.
All right. Where were we? So that was 74, 72, and 77. You guys asked for. Okay. Oh no, we did 74, 72, and 77. All right. On 72, you have a triangle of each sides is. Oh, this is not on the test.
A triangle with sides is a cube, right?
Get rid of those. Those aren't on the test.
What is it?
That's in semester 2.
But is it
I'd have to figure it out. Hold on.
Oh, you do math? Oh, wait. Think it right now. I'm gonna guess.
Yeah, no.
It's gonna be C. I know it is.
always C?
It'd be obtuse.
Oh, you were wrong.
Who got number 69?
Deal with
What's
it,
the class?
Zach.
It was Zach who guessed.
Deal with it.
Do you want me to go over? It's not going to be on the exam.
Did you
No,
just
I don't know. That's what's the time then.
So this is one of the first things we do when we come back from winter break.
Wow.
It's Pythagorean theorem, basically.
Oh, why didn't you just say that?
But Pythagorean theorem can be used for more than a right triangle.
What's the answer for 82?
That gives you a right triangle. If c squared is greater, then it's obtuse. And if c squared is less than, it's a cube.
What's the right triangle and a spiral triangle?
So, huh?
What about C and D?
You can't, well, equilateral, they'd all have to be the same measure.
Oh, okay.
So,
Just tell that from.
yeah, you just look at it and know that one. But that's what we come back to after break. All right. So yeah, cross those off. Oh, there was one other one I noticed that was from after break. What number was that?
Well, we don't have to complete that, do we?
Well, it's just on here by accident, I think. Number 90.
No way.
90, cross that one off. Not on this exam. It looks like something that would be, because it looks very similar to what we did in the last section, but it's based off of the idea of 30, 60, 90 triangle, which we haven't done yet, and 45, 45, 90.
1 hour and 13 minutes and 50 seconds. 1 hour and 13 minutes.
Probably not going to happen today. Tomorrow's conference night, I'd like to have them in tomorrow. I don't know if,
Tomorrow's conference?
yeah, it doesn't make any sense, does it?
That's weird.
Yeah.
Wait, there's conference right tomorrow. I didn't even know that.
Wait, what?
I
There is?
hate going.
Stupid.
Why do they do that? On your computer? Like, it's not like any of the teachers are going to change anything.
Yeah. All right, I'm going to stop this recording for a second because I don't want this recorded anywhere.